and good day or good evening or whatever time zone you are in. Fantastic to be able to talk to you all about this project up in middle of Sweden. It's called the Coordinating Power Control, and Sustainable Innovation is a company where we try to create a bridge between entrepreneurs, big companies, and academia in actually doing projects that implement changes. And we work mostly with in the area of energy systems and buildings and transport. And short agenda is about the project, why we started it, how we do it, of course, and what we're doing at the moment, and some results in the evening, in the end. And then I will point a bit to the future we are doing, and hope to be able to interact with you all in the Q&A. The Sustainable Innovation has a number of member companies, which is both the Vattenfall utility and also consulting companies, even Toyota around transport, and of course IoT is one of the big things with Intel as part as well. And we try to do the development projects where we go from initiation down to the actual results, which is usually called the Death Valley for entrepreneurs. They have received these research funding, and then the projects need to increase and get out to market, and that's where we do most of our projects. And we're doing some 40 projects at the moment. And one of those is this Coordinating Power Control that we was awarded the ISGAN Award of Excellence this May, which was a fascinating thing for us, being such a small project. We have a turnaround in the project of around 4 million, that's 4 million, that should be 400,000 euros over a 4-year period in state funding. So it's a fairly small project, but we are able to do it quite wide between stakeholders. And I'll get into more about that during the presentation. So why did we start this? Well, the first start actually was already started in 2014, and we were actually just started because of this. Smart homes, I've been working a lot with the IoT development. I've been part of the utilities in Sweden doing a lot of things around the changes where we could start to control devices in the home, taking demand response to the next level. And suddenly Conrad and Kjell Company, the Swedish device company, has this spring campaign of smart home devices. And as you perhaps noticed, IKEA is now selling smart lamps. They are even going into sound systems, and now their first smart plug has arrived in the IKEA offers. And it's also, since you start with those smart plugs, there's already Wi-Fi connected radiators, some of them around 1 kilowatt each. This big one here is a heater with 2 kilowatts, which is sort of fixed mostly in summer homes, in Sweden anyway. And it's very close for these to start acting towards the electricity price. Everybody talks about electricity price as the solution for being more active. We have had hourly pricing for a long time in Sweden. I think there's around 2,000 to 3,000 households that changed to hourly pricing, meaning domestic customers, which is very few. Most of them have average monthly prices, so it's not much of an incentive. But as soon as these devices start to actually act on those prices, we've shown in a report that it will be quite problematic. The example here up to the left is an ordinary price curve. And when we then induce onto those bids that we are a deregulated market in Sweden. We have a wholesale market on energy, and we have a monopoly on the distribution side. So there's a lot of different companies selling energy to hourly pricing. And when we have used the bidding data from the North Pole market, we then induce the different actors that start to act on those prices. And with the 100,000 units, heat pumps, these radiators and so on, the pricing will start being quite volatile. And it could even be very hard to predict when these devices will act on the price. And if we have 700,000, we have a totally unpredictable market. And that is based on the day-ahead market. So when you have closed the day-ahead market at noon every day, you have then a market for the intraday where you actually have the on-demand control. And doing this, you will move everything more or less over to the intraday, since nothing will be as it was thought of from the beginning during the first bidding process. So this is quite problematic. And the only way to solve this, more or less, is that the wholesale companies need to connect all the smart devices. And being the fact that the smart devices will be an infinite number of different companies, how do a wholesale company open up their bidding process towards IKEA smart devices? Or different heat pump controllers, or different companies, Ado, Net. It's a myriad of different devices. So that's more or less where we started this project. What will happen if we induce this in a local grid? The next thing to look at is the EV expansion. And this is a report from Sweden, where they planned on the 5 million EV cars in Sweden. We now today have 66,000. So, but it's increasing very fast. And if we just had 5 million EV cars, and just looking at the afternoon peak of charging when people come home from commuting to work, we will have estimated power peak of 3.8 gigawatts at the afternoon on a Thursday, actually. But if we instead have controlled these chargers and actually connect them to the grid, or to some control logic, we could then lower that to just about 1 gigawatt. So being able to do the actual controls makes a huge difference. And it's also the fact that these chargers are added in the grid just as smart home devices are. The only way grid owner would notice if somebody is adding a car or a charger if they need to increase their fuses, because that's the only way net company or the grid company takes the charge, the cost today. And today there's even, at least in Sweden, offers where you buy your EV car and you get a one-phase 3.7 kilowatts or even 7.4 kilowatts charger given to you. And there's subsidies for installing home charging. And there's also a tendency in Sweden to ban all the 230, 2.2 kilowatts charging in ordinary sockets, because there's been a lot of fires. Well, not a lot of fires, but there's been some fires. So that will also make it problematic for a DSO to know all these smart home devices will suddenly pop up in their network. These chargers will pop up in the network. And today, the DSO has a big challenge since they have peak tariffs. So this is a monopoly company having a peak tariff toward the regional grid or the TSO grid. And these fines are, in Sweden, quite large, and they will increase. The TSO has already advertised that these peak fines will be much more, since the TSO will push down costs on peak costs, mainly because the TSO needs to add more and more production and reserves to keep the balance. So today a DSO needs to optimize this, and either he just dig down a lot of cables if there's any problems in the actual capacity, or he will start controlling these devices. So that's the main issue for a DSO to manage these peaks. And when he's doing that, he actually is moving energy, which we, back in the first picture, saw that the energy companies must take in charge of these devices based on the wholesale market. So there's a total clash between who to push the button to control the actual devices. The local grid company that has these fines, or the overall wholesale company that has an energy cost. And these will probably be some coordination between these peaks and the cost of the energy, but it could also be counterproductive issues. So looking at the next level of complexity in Sweden, we today have capacity, a low capacity in the Swedish grid. It's mainly in the transmission grid, but there's also regional grids that have capacity problems. And definitely we have already in the big cities, such as Stockholm, Malmö, and Uppsala, capacity problems. And this is these are news flashes just from this autumn, where we see a very quick increase in new network connections. The grid companies have never seen such connection demand. The cities are expanding quickly, and for example, Amazon, it's the kind of company that sort of within half a year they can say, oh, we add this data center. And usually Swedish utility or grid companies, they have a planning of 10 years or 5 to 10 years. So having something that should be put up within within a year or so, it's a totally new area. So we need to move up the capacity problems on the agenda in Sweden very quickly. And this spring we had one of the biggest peaks, or quite big peak. We had a peak of 26,700 megawatts per hour. so that's the power. And that's on the TSO balance level. And at that time, we actually were having a total amount of import. And we also had already here turbine capacity set on standby. We never needed to put that into work, but already today we are at a level where we need extra capacity or extra power reserves on the TSO level. And in Sweden today we're working in 4 different price areas regarding the energy. So we have congestions around the TSO grid that makes these different price areas. So it's a much lower price in the top because it's here where we have all the production, and then you have a much higher price in the lower price area. So combining all these, we see that the overall system needs more production capacity for peaks, and we have a lot of regional problems around cities. So looking back down again towards the energy system in Uppsala, which is in the middle of Sweden, we have a small grid where we work with this project. And if you look at Sweden, it's just above Stockholm, outside the big town of Uppsala, where this smaller grid is situated, and that's where we do in the coordinating power control project. So how do we do it then? Well, as I mentioned, the focus is on the DSO challenge. So this is for this local DSO grid that we are focusing on today. And we're doing it through a lot of aggregators, and the DSO target is then to keep down the peak. So we combine 3 different aggregators, and having 3 companies, which is very good, one of the best ones in Sweden. I am sure you have some ones of these in every country. So looking at this project, we think that, okay, we have 1, but there's at least 10 different heat system controllers. There's at least 10 different charge system providers. And of course, there's also battery and energy controller things. So these are more representative of 3 different aggregators that will end up in different homes, providing their services. So we then try to combine that. So the overall goal for the Vexel project was to empower 500 homes in the local distribution grid, show that that would make a significant impact. And we have shown that we could, the goal was to get 1 megawatt of manageable power with water-based inertia in villas. And we also would like to have an energy efficiency goal, since we need to change the levels. And then we added 10 batteries in domestic areas, 7.5 kilowatt hours in each, and they have a 6 kilowatt inverter, so they can provide each 6 kilowatts of power, which is a very bad calculation. 10 units of 6 kilowatts would be 60. Really sorry about that. And then we have chargers, 10 chargers, which also have a bad mathematics. 10 chargers of 3.7 would be 37. Again, sorry for that. I'll change that in the official document. So when combining these assets, we can then start fiddling with the business models to share the profit for the DSO And we also have a part where we look at the customer feedback and what they think. So the goal is to actually change in doing totally dynamic tariff models instead of just fuse-based tariff models. And the DSO, just short of what we are into, it's 14,000 customers. And I mentioned they subscribe on a 60 megawatt power. And they've been customer-owned for over 100 years. And that gives us a very special possibility, since everything we do with tariffs and so on will then, if there's a gain for the DSO company, it will be a gain for the end users. So that gives us a very pleasant way of being a regulatory sandbox. And the fact is that this grid has 40% lower grid costs than the grids around them, although they have the same number of cables per user and the same problems. So they have decided to use tech to continue having these low grid fees. And if we look into the DSO grid, they have 3 intake points and 1 major straight-through wire. So it's a very horizontal grid, and there's congestion being in this horizontal transmission. They cannot transport energy from just one point over to the other side of the grid. So it's impossible for them to actually disconnect one point and still be able to feed the whole grid. So that's also a fact for them to be able to use demand flexibility in case of problems in the grid. So using the Energyhub system to have the water-based heating system added, we just add a little device with a connector between the outside temperature and the heat pump or the boiler. So in Sweden, any heat control system look at the outside temperature and creates an inside temperature. So this system will very easily take the outside temperature and then use an inside temperature sensor and a lot of AI to make a forecast of what you need in your house. And then we have Energyhub from Ferroamp, where we have a battery connected to a local DC bus. And we have the Energyhub connected directly at the main meter for the house. So in that they can remove all three-phase inequalities. So for the grid owner, it's only a flat usage level. And we can then back power from the batteries 6 kilowatts back to the grid to feed it with extra power when there's a peak. With the technology, we could also connect several houses with a local DC nanogrid to make them act as a local energy community, being able to provide energy out to different networks from the different meters. And we also, over this DC network, we directly connect solar panels, batteries, and also there's a plan now to add on to DC charging. So we minimize the amount of AC-DC converters based on this technology. And then, of course, we have the charging infrastructure. And we use the company ChargeStorm and their connected charging points, which are more straightforward. And we don't have any vehicle to grid today. but we use only this lower the actual charging. So what the level today is that we have all these installed. We're now starting to actually do the control logic. We have had long discussions on whether to use market technology, offering houses to have some kind of market of power in the local grid. But we have ended up in a model predicted control, meaning that we have the overall control logic for all participants, having the ultimate goal of lowering the power peak in the local network. Being local could be more or less any size. With doing this, we've found it more easy to get the ultimate control done. And we are on the level now that we have implemented this, and we started to deploy it towards the different aggregators. And that's a very tricky discussion. How do you connect aggregators? When we look at charging infrastructure, we find that the current state-of-the-art protocol is the Open Charge Point protocol. And that's a whole group of companies working with that protocol. It's open, it's good, but it doesn't have the logic to be a power coordinating system in itself. And we also look at the solar systems, and they are working with the SunSpec protocol. And of course, the heating systems have their own proprietary systems towards heat pumps, toward devices. So that's a very tricky area. And it's also more or less the same regarding the battery technologies. Battery monitoring systems are not really an open standard. So therefore, we backed up to the technology OpenADR. And I would really like to have a Q&A about what your feelings are about this standardized problem. Where should an optimizer logic move in? So we have now implemented an OpenADR part where we have the logic, the MPC logic, working towards these three different companies. And we get data from the local DSL. So that's where we are today. And we just started with the director of our energy department who pushed the button on the 27th of November. And as you see on the right here, you have an ordinary home installation of a solar edge inverter, which will be removed just within a week or two to have a straight DC converted down to the Energyhub and a battery. This winter we will then do our first really interesting tests of the overall logic, where we will use as much assets as possible to optimize the DSO. And that will then lead to the fact that end user saving solar energy on the day, we will use all that energy to help the peak during an hour, since we have 7.5 kilowatt hours and 6 kilowatts of inverters in the batteries. They will totally empty the battery during the peak, which will be interesting to see the value of the energy contra the value of the peak management. And what do the customers then think about us doing this. And what are the results? Well, as I mentioned, we had in February this power peak. They were situated around the end of the February month and the beginning of the March. So it was the 28th of February and the 1st, oh sorry, I'm not pointing. It was 1st of March and the 28th of February. And the construction in Sweden is that the highest peak hour of 2 months over a year, which was then suddenly done within 24 hours at this point. So that's one of the challenges we see, that, well, is a monthly hour peak pricing actually a good thing? Or what are we really wanting to do? And during these 2 points, we were controlling the spring. And we had 250 houses with water-based heating, and we also had some of the batteries in place. And you have on the left here, this is the red curve is the actual usage in the grid. And we had a model following that curve precisely. And then the model predicted that this would be the usage over the peak if we didn't participate with our control unit. And the model then continues to be part of the half hour before and half hour after. So therefore, we can say with at least 98% accuracy that this model would give us the right value. And if we look at what we have, if we haven't been able to control these systems, we would have a power peak at around 61.5 or 61.7 megawatts in this grid. And as you remember from our first point, they were subscribing on 60. And the actual fine that they got from this little peak, where we started, and we have sort of 15 minutes before we get to be really good. This peak costed 13,000 euros for this grid owner. But we actually was able to remove almost 1.5 megawatts, which was then worth over 48,000 euros. And that's with an energy usage of just 1,800 kilowatt hours. And the value in the Swedish network for that amount of energy is around 200 euros. So you see the difference in value between power and energy. It's a huge difference in the Swedish system today. And what did then the customers think? I'm sorry for the Swedish in the graph. Oh, sorry. This is in Easter. We were making tests, and this is our around 300 participants. And we told them on the long Friday that we are going to have control over your system during the weekend. We didn't tell them anymore. And after the weekend, we sent out the questionnaire, and most of them actually didn't answer it. But there's around 100 that actually answered the questionnaire. So what did they think about this? Did they notice anything? And the majority of the 100, they didn't notice anything. But there were around 30 that actually noticed that they were controlled. And from those who noticed anything, most some of them were not having any complaints about that. And actually, one of them were actually part of the control. But the majority of those who noticed the control and felt uncomfortable with it were not participating in any control. So it was totally a placebo result. If we hadn't disturbed the customers at all doing this control, nobody would have noticed anything. And that's because we don't do control more than 1 degree in their home today. So being able to participate in demand response is more or less a decision you take in the beginning. You choose to be part of it. You choose to do this, and then you really don't like to be so active. That's at least our results, what we feel when we talk to these customers. And then I would like to talk about the difference, because we use real-time knowledge. And Cozy Friday is a saying in Swedish where we have all families gathering together on the Friday. And this is a Friday evening, and these are the hourly power, average power. But as you see here is that you can have a very high peak based more or less on a TV program. Something happened, but only not in the whole house. It's only in this part of, this is 2 parts of a building complex. And having these peaks is what we are aiming for. Sweden will soon adhere to the quarterly pricing, the quarterly energy balance. So that will be an interesting future, having more of power into the energy mix, or the part of the energy wholesale market. But I think we need to go even further into more detailed values to get this getting power to be more dominating in the mix. So what's the future now? Well, we are, as I said, installing, having winter tests running. We will transform this into a major test bed, which we will just launching now. And we also have a EU project connected where we are looking at getting a blockchain distribution of the values. As mentioned, the DSO is now getting the value, and the participants are having nice features as a cool app, being participating, helping the world. They don't give any financial fee results. So looking at the blockchain way of moving results, this will, in the first step, be between the DSO and the planning part that will be written on a smart contract. DSO will prepay with tokens the value that you use in this control. Then the control will actually happen together with the aggregators, and there will be a settlement process of these values. The next step would then be to have the end user into this smart contract. So the settlement would continue trickle down to the actual end user over the aggregator. So that's what we will be planning in the next year together with the Nemo Grid project. And we also look at the total Uppsala region, which is 6 different TSO grids, which have an 80 megawatt of capacity loss, capacity need that's not possible within 10 years from the TSO. So we have several projects around these different DSOs. And the interesting thing is now, could the DSOs help each other out to get the Uppsala city be able to expand? Using lowering power in the suburban areas to help the city. That's a very interesting question, and that's our aim, to be able to have this test bed helping that to happen. And there's also regulatory issues on local energy systems, because we would like to see this as a local energy system around this problem of the 80 megawatts. And one of those is, I don't know if you have them internationally, but we have buildings that are now disconnected as three-dimensional ownership. And using the electricity grid, these different owners cannot share energy because they have different electricity meters. And but if they do it on heat, it's possible to have this as a whole energy system. So how can you create local energy systems, and where are the boundaries for that? That's what we need to do as a regulatory sandboxes. This is a condominium villa organization. They have a transformer in the center, and it's 64 houses that more or less share this transformer. They have good of situation for solar. That's a lot of EVs and a lot of place in the garages for batteries. But they are not allowed today to create an energy community to solve the power issues in the transformer. So that leads me to what is a local energy system, and where do you optimize it towards what? Well, you have a DSO grid that's really a small piece of the puzzle, but there's a lot of them, and they will, if they optimize towards these peak differences, they will help the whole grid upwards, all the way up to our world. Well, at least if we get the super grid connected. So I hope to see future energy systems where our rural areas help smart cities to manage peaks, to be able to cope with all these different price areas. And that will be very interesting.